welcome back. I hope you had a nice embodied outdoor break. Um, we're going to continue now talking about David Kirsch, his 7 principles for how externalized cognition is not only making the original task easier, but also enabling us to do things that we couldn't have done otherwise. Um, I'm going to try and go rather briefly over the 7 principles. Of course, in the course itself, in the activities we have together, you have the chance to discuss this further and ask questions. It's based on this article here, Thinking with External Representations. So the first is the idea of shareable and identifiable objects. In the top, you see David Kirsch is discussing. He did a lot of work with dancers and choreographers, and he's looking at this one particular famous UK London choreographer. Think of the National Ballet or something like that. And he uses physical. He makes all kinds of lines. He physically makes gestures in the air, and then he draws these things around it to sort of exemplify what he means with the movement. So by drawing these extra lines on it, you sort of um, um, you can better understand what the dancer is actually trying to communicate to the choreographer, what he's trying to communicate to the dancers. And I've seen this a lot in my own research. For example, on the bottom left, you see 3 designers talking about a project for a water cooler system from a big design company in the Netherlands. And I've been observing these conversations. And the funny thing is that you would think that they were talking actually about the water cooler, and they do in some way, but they are also talking about all kinds of other stuff like the politics of the project and the power play and so on. Lots of meta level discussions around this water cooler, and it's literally happens around this water cooler. So they're using the prototype to talk about all kinds of stuff, and they have a shareable, identifiable object that they can point to, reference, walk around, show to others, and so on, in order to express what they have in mind. The second important principle is rearrangement. And of course, the common example is if you make a puzzle, like the one on top, um, by rearranging the objects, um, you make the task of seeing which puzzle piece goes where much easier. So this is the same as the Tetris example or the example of this colleague of mine who was using um, a physical layout of objects in order to solve the task. Related to that is the idea of persistence. If you represent the problem in physical objects that you can put outside of your mind for others to see, to share with others, but also to reflect on yourself, um, it cannot be the case that physical things cannot be in 2 places at the same time, and also 2 physical things cannot be at the same place at the same time. This is a feature of nature, of physical reality, but of course, it's not necessarily a feature of abstract information. So abstract information, if you try to keep it in your mind, things can muddle up, so to speak. But if you make them physical objects, then it's much more easy to keep things apart and not confuse things, right? The next point is reformulation or explicitness. What we often do when we try to tackle a difficult, complex problem that is sort of vague and There's too many things at the same time we have to sort of keep in mind, and too many things at the same time that are important. Then, before you know it, we will start to express it physically outside of our mind, to fix it, to make it into something that is explicit and that is no longer changing all the time because it's fuzzy. Um, so this is about converting expressions, fake thoughts, into more explicit formulations. Because in your mind, things go everywhere, but once you write it down, once you put it into a drawing, a graph, it's sort of you fixate your thoughts, right? This can also be a problem, right? So designers know very well that if you, as soon as you start to draw, on the one hand, you make things very clear for your stakeholders and for other people involved, but on the other hand, it also, before you know it, it starts to frame the problem in a certain way, and it becomes difficult to think outside of the box you have just created, right? And of course, thinking outside of the box is also important for design. So you need to, as a designer, you need to very quickly make something explicit in a drawing or a prototype or whatever, but you also need to be able to sort of cross it out again and start with a blank slate. So switching between that is actually one of the things that good designers are good at. So typical things for reformulation of explicit or explicit are when somebody says, "Oh, wait a second, let me write this down so we can get clear on what are all these things. Say again, what were you saying that was important?" And you write it down and you make a mind map out of it, or a list, or something like that, right? Or if somebody makes a sketch of it, like, "Oh, you're talking about what you want to redecorate your home. Well, let's try. Let's. You have all these ideas. Let's make a sketch. Do you mean something like this?" And then it starts to become explicit. People are saying, "No, I meant the couch." Well, yeah, if you put the couch there, yeah, that won't work. So, by writing it, by drawing it, you also encounter the possible problems. For example, going back to persistence, if you want to redecorate your home and you have this vague idea of a couch and the cupboard and the chair in the corner, and somebody else starts to sketch it, and then you immediately see, oh, wait a minute, those things will never fit all at the same time in the same corner. In your mind, everything was possible. If you make it explicit, you see what's really possible. Um, and then, of course, there's the famous what is your research question. So if you're a student in the university and you're doing a graduation project like a bachelor's or a master's project, everybody has had these same conversations over and over again with their tutors or supervisor saying, okay, but what is your research question? Write it down. Can you write down in one sentence? Can you make a short abstract? Can you write it down in 300 words? What is it exactly that you want to do? Can you make a plan? Can you make a Gantt chart of, can you give me some deadlines, right? So all these things are about getting a grip on a complex problem by making it explicit. Now, and then there's a very interesting thing that came out of this work of David Kirsch with the choreographer mainly. The choreographer that he worked with used his own body to explore moves that he wanted to put into the dance. That sounds very logical thing to do, but of course he could have also have chosen to sit on a chair in a corner of the room and think in his head purely about these movements. And maybe sometimes he also does that, I don't know. But at least what David saw was that very often the choreographer would stand sort of aside from the actual dancers and try out things with his own body and then say to the dancer, wait, I've got a new idea. Try this. So you use the medium in which you eventually want to express yourself as an research tool to investigate what you want to express and how you want to express it. So the same is true with musicians, right? So if you want to think about a new tune you want to play on the guitar, you don't go do that on a flute, or you don't go do that only writing on paper. You just grab a guitar and you start to play, right? You try it out. Now I think if you become really skilled, like famous composers, for example, At some point, I think composers almost don't need the musical instrument anymore. Everything is, they've got the whole thing incorporated into their own body, and they can just play the piano without having an actual piano. Very good chess players can play chess without a board, right? But it's reasonable to assume that it's more difficult and you need much more training to do it. So if you think in David Kirsch terms of what kind of computation is cheapest to perform, um, uh, creating a new music piece, composing a new music piece for guitar, the cheapest way to do that computationally is, in terms of the cognitive science, the cognition involved, would be to do it on a guitar or with a guitar. If you prototype a product and make shapes that actually resemble as closely as possible what you have in mind for the eventual product that you want to produce in series in a factory, creating a prototype is a very good way of exploring what the product should look like rather than just working in 2D sketches, or for example. Now, continuing a little bit on the idea of design, of course, I'm working with designers in industrial design department, so a lot of my examples come from design. But this, like David Kirsch, is focused on everybody. So human beings in general, in every profession and in your everyday life and at home, you do these things, right? But I'm having some examples from designers, not because that's especially applicable to this theory, but because this is the world that we live in, right? So, for example, if you want to deal with very complex problems, what you often do is use multiple representations, multiple and different ways of representing the same problem. And each way of representing the problem gives you a different angle, a different perspective, or what we call a different frame in some way on the problem. And this works well for problems that are so vague and complex that there isn't one optimal, most best efficient representation for it. So when you design a new interactive system that's going to do some kind of work within a human practice, these pictures are for lamps that are supposed to be sort of visual reminders for people with mental impairment, intellectual impairment, to remind them of things they don't want to forget. Um, in this whole project, we made several different kinds of prototypes, and we also made paper prototypes, as you see in the bottom left, where you could play out the scenario of how you would use the product. And in the top left, you see, for example, the technical prototype in the sense of what kind of technology is involved and how is the technology connected. Um, how are the different components connected, right? And so you need all these different representations to get a full complete sense of the product in order to be able to say, is this a good product or not, right? There's not one best prototype, one best representation. Now, to continue on prototyping, what David Kirsch says that construction and tools, and he's a bit general about this. So actually, David Kirsch at one point started to work together with industrial designers, and that was for him rather a new field because he came from computer science, and he found out that industrial designers actually have an interesting focus traditionally already on creating physical objects, right? So this whole idea of distributed cognition was came very natural to them in their own way of working. Um, and so David was very inspired by that. So he started working, for example, with Eindhoven, where I was doing my PhD at the time. Now, um, what he says is there's some kind of magic in actually making something in the world. I don't know if magic is the right word. He was maybe sort of very um, impressed by it, how it works. Um, but you could say it's actually just a combination of these three things. It's if you make a prototype, and if you make prototypes not as the final expression of your process, but as part of the thinking process, right? So as a designer, you're prototyping, making iterations of prototypes in order to get more clear on what you actually want to do and how you're going to do it. Then prototypes are they are persistent, so they really put you with the facts on you, with your nose on the facts, like you had some vague idea of doing something. Well, that doesn't work because you cannot build it. So if you can build it, it's possible, right? So actually having to build something already makes things explicit. You can use the prototypes to rearrange stuff, reformulate, and make your ideas more explicit. So all these different principles that I've just been discussing, taken together, they are all part of this magic. If you put them together, it looks like magic maybe, but it's not magic at all. It's just a very natural way of finding out about stuff that designers do. So as we saw in the previous lecture, um, on tangible interaction, you can now see that tangible interaction is actually an application of all these kinds of strategies with which human beings make life easier for themselves, and they don't have to think so much because they let the physical world do part of the thinking for them, if you wish. So Kirsch says here in the paper, when a structure is viewable, drawable, when its properties prime a constellation of associations, just by grappling with the external material and then looking at the results, a set of properties and possibilities of forms are encountered and primed. Now, this is exactly what you do in these examples from Hiroshi Ishii, where you can manipulate, like the one on the left I didn't discuss yet. So this is for architects. The idea is that you move the buildings, the representations of buildings, and digitally the airflow and the shadows during the time of day that you select are projected immediately. So if you change the orientation of buildings for a new site that you want to design, like a new neighborhood or something, you can immediately see where's the shadow on what time of day, where's going to be gusts of wind that you don't want, and so on. And you don't have to calculate that. You don't have to use all kinds of fancy mathematical models for it because the models are in the way the system works, and you can just play around with it in a very natural way. And then uh, um, new properties and possibilities of forms are encountered and primed by playing around with it. So that's what tangible user interfaces afford. Or consider this example where game designers are moving um, uh, avatars. It's actually quite difficult to move your avatar using mouse pointers and so on in a 3D projected space. But if you have a sort of physical object that represents the digital object in a little bit more abstract way, you can easily move the puppet and then have the computer just copy those movements. And then for the user, for the designer of the avatar animation, it becomes much more easier. I also show this just to say that in the ACM proceedings, so that's online, the Association of Computing Machinery, they have all the proceedings of all their conferences. So it's all computing science conferences. And there's this one conference that I'm involved in, conference on tangible, embodied, and embedded interaction, TEI. There's one E, I don't know why. And there you find, like every year, there's like a wealth of new applications of tangible interaction, or anything to do with tangible and embodied interaction. So you can find a lot of inspiration there. So I would really encourage you to look that up. So yeah, what is the difference between tangible and non-tangible interaction? It's not a black and white difference, I guess. It's sort of in practice, in actual systems, it's always a mix of different things going on at the same time. But for example, if you compare these different ways of making drum beats, right? So top left you have a classical drum kit, an analog drum kit. Top right you have a very linguistic and functional drum kit with these sort of traditional. This is the kind of machine that almost looks like your microwave or a video recorder. All the same kind of buttons. No intrinsic meaning to the buttons. You have to learn the symbolic rules in order to operate it. And then so there's a clear difference between those two, you could imagine. And then the bottom ones are sort of mixtures of that. So the bottom left one is a system called the reactable, and I will show you.
Reactable is a tangible computer music instrument based on a table. The Reactable started as a project 2 years ago, and as unlike many projects which involve a lot of technology, it started from a concept and not from a technology. So first we knew what we wanted to build, and then we discovered how to build it.
Tangibles, they still symbolically mean certain things like rhythm or pitch or volume or all kinds of reverb and effects and filters for making electronic music. And then on the bottom right, you have sort of the same system, but then completely digital on a tablet. And yeah, the open question that I don't have the ultimate answer to is how do these systems compare? Right? And it can be personal for people. It can also be a matter of how you are trained and educated in using these systems. But at least, even if we can't say that one is necessarily better, so to speak, in an absolute sense than the other, you could imagine now, having all this knowledge that I've been discussing so far, that there are differences in in what it does in terms of the cognition of the user to work with these systems. There are different qualities of interaction being displayed here, right? So I hope you can now sort of imagine that, even if you cannot readily say, well, one is better than the other, because I don't think that kind of statement is possible anyway. So theoretically, some conclusions here. Um, we've talked about, and these are some slides with some more text, so watch out. Um, We've talked about external representation, so putting information out there in the world so that you don't have to keep it in your mind, internal mind. And the more radical claim is actually that that means that the mind, what we say is the mind, is actually then becoming partly external. So the external objects that play a part in this cognitive process, well, you can say, well, they are then part of your mind, right? So your mind sort of extends out into the world, the extended mind, as Andy Clark calls it. It's external representation, and you have external computation. So external representation is just sort of storing information in the world so that you don't have to store it on your internal hard drive. External computation is manipulating this information physically with your hands, moving blocks around, and by doing so, um, doing a reasoning. So drawing conclusions, comparing things, getting an insight about something, right? So it's the activity of working with information. Um, and this theory that comes from Ed Hutchins, David Kirsch, Andy Clark, Jean Lave, and all these other people. That's a theory that can be used to design natural mappings, as Donald Norman calls them, from physical interfaces to digital content. Right? So the idea is you have a digital system, and the question is how to design a good interface to this digital content. And you could say that these mappings are natural. The reason we call them natural mappings is because these designs make use of the various ways in which humans use the external world to think with. So we are born to use the world externally as a tool to think with. That comes naturally with how human beings work. And if you then design it for it in that explicit way, that makes life easier. So it feels more natural. But as I already said before, what comes natural or what feels intuitive, of course, is a relative question. It may be that you have become so used to icons, pointers, textual interfaces that switching to tangible objects on a table and moving them about doesn't feel natural to you anymore. But here the claim is more that, well, it is still more natural. You've just outgrown the habit, and you've been so sort of conditioned into working with text and symbols and more abstract interface elements, non-tangible interface elements, that you now think it's more actually more difficult to use the tangible interface. Um, I don't want to make any strong claims on what's actually the case here, um, but you could in any way see that this principle of by representing the problem, suddenly the solution becomes trivial or evident, right? And you have to do much less cognitive processing and thinking at that moment when you've sort of shifted things around to so that it becomes a simple pattern matching task. That kind of stuff is, yeah, you could say that's more natural to us, right? Then the task is easier for us. Now, intangible interfaces are, you can see as applications of this principle. So to conclude, tangible interaction makes it that the interface to digital functionalities fits well with with our human body's capacity for thinking with things. So as David Kirsch says, we think with things. That's and that's because we have bodies, so we can manipulate objects in the world, and we can use that to think with. Tangible interaction makes explicit use of that in order to connect our activities to digital information. Now, but that's not the end of the story, because what about Descartes and this split between mind and body, right? I said we were going to resolve one split today, and that's the split between internal and external. So you could say that we have sort of resolved the split between the human and the external world, and we say that if a person is solving a cognitive problem, they are using the external world, objects, as well as other people in the way that Ed Hutchins talks about it. So remember this: the people on the naval ship. It's just a bunch of people and tools together forming one big cognitive system. So the cognitive content, right, the information that we are processing is not purely taking place. Information processing is not purely taking place in our brain. It's taking place in our brain, but also in the physical representations that we manipulate with our hands in the tools and in other people's brains. And we form one networked system, if you wish, right? So the information is physically realized not only in our brains, but in also in the external world. So the content and the physical carriers of the content, the physical carrier of content is not just the brain, it's not just neural processes, but also just moving about tangibles on a table is also part of the cognitive process. But there's still a split, and the split is between the content and the physical carriers, right? And in the the lectures to come, we're going to try a little bit to see if we can also remove that split. So we have no splits left anymore. So going beyond the idea of external representation, so this is one way of looking at embodied interaction, is saying embodied interaction means that people use external representations. And if designers make use of that, they're doing embodied interaction design. And that's true. And most of tangible interaction is like that. But Ed Hutchins, who was the guy from distributed cognition, who studied the Navy ship, he already said that it's not just tools, physical objects, the nautical slide rule and so on, that we use to think with. We also use the interactions with other people in a social setting, a social practice. And social stuff is different. We're not just using people as tools, right? Sometimes we do this, but the social interaction with other people has a different character. You cannot just explain it as external representation and computation anymore. There's something special going on when people start to interact with one another. And through that, people also can understand and make sense of the world in a way that they could not do all by themselves. And we're going to talk about that in the next lecture. And then the lecture after that, we're going to focus on skills. So if we think about embodied interaction as skillful dealing with the world, um, physical manipulation over time becomes a habit, and skilled habits are also more than just externalized physical representations. Now, all of that is still very vague at this moment, of course, but we're going to dive into that and work our way through. So, next lecture is going to be not about the external world as a physical representation of digital information. We're going to talk about embodied interaction as fundamentally a social practice, and we're going to talk about people and how people interact and make sense of stuff together.